episode 9, we are here to present about an electric motor in the washing machine. Before we start, I will introduce our group member for this assignment. The first one is Afza Nurdini binti Mahadi Hassan, matrix number S64730. The second is Muhammad Azmar bin Hamzah, matrix number S64726. Third is me, Nurul Husnina Lamia binti Mazlan, matrix numbers S64658. Fourth is Farha Nasuha binti Zamri, matrix number S64718. And the last one, Nur Fariha Mulyanis binti Anwar, matrix number S62546.
The universal motor is a type of electric motor that can operate on either AC or DC power and use an electromagnet as its stator to create its magnetic field. The universal motor is very similar to a DC series motor in construction, but is modified slightly to allow the motor to operate properly on AC power. This type of electric motor can operate well on AC because the current in both the field coils and the armature and the resultant magnetic field will alternate reverse polarity and synchronously with the supply. Hence, the resulting mechanical force will occur in consistent direction of rotation, independent of the direction of applied voltage, but determined by the commutator and polarity of the field coils. The universal motor is very similar to a DC series motor in construction, but is modified slightly to allow the motor to operate properly on AC power. The reason why washing machine use universal motor because universal motor is a type of motor that can operate on either DC or a single phase AC source. Because this motor usually series one the armature and field windings connected in series. They have a high starting torque. See the characteristic of DC motors here. As a result, universal motors usually incorporate into the device they are supposed to operate. The majority of universal motors are intended to run at higher speeds than 3,500 RPM due to the reactance voltage loss that exists in AC but not in DC. They operate at a lesser speed on AC than they do on DC at the same voltage. Universal motors are divided into two categories. The compensated type is the first and the second is uncompensated type. In addition, not only washing machine use universal motor, but many machines that use universal motors such as blender, vacuum cleaners, and hair dryer, where high speed and lightweight are desirable.
Both figure shows the universal motor that has been used in the washing machine. This type is from the male washing machine motor. There is a plastic cover on the pin and we can remove it to see the pin itself. Universal motor consists of 10 pins started from the left side, which is pin 1. Pin 1 is for protective earth that connect to the enclosure of the motor, while on the right side we have pin 9 and 10 that will connect it to the taco coil. And for the other pin, which is pin 4, 5, and 6, is for the brush and the armature. Commutator is a ring with a gap in the opposite sides.
It will spin along with the armature. There are two brushes that connect it at the side. It will slide along as commutator spin. When the current flow, it will go through the brush to the commutator ring, the loop, and back to the other side. Now we have electromagnet and the armature spins. The brush will switch to the other side of the commutator ring. Since we have two brushes, so it will happen at the both sides. Before it change, the current flow from the left to the right, and after that, the current will flow in another way. Electromagnet will switch polarity to keep the armature spinning. Commutator ring does same thing. It will keep spinning as long as it connected to the power supply. Since we only have one loop on the armature, it might stop and having an irregular speed. So we have to split the commutator ring and add another loop. The brush will contact with the segment to turn on the selector magnet and it will start spinning. When the segment is changing, the loop will turn off and the next loop will turn on. This will keep happening as our motor spins. The loop is take turn being an electromagnet. Some electric motor will add many loops to the armature to get the continuous spinning motion on motor. The spinning force on armature is called as torque. The stronger the torque, the faster the spin. To improve the torque, electromagnets are stronger when it has more wires. That's why we can see each of our armature loops are made of many wires.
Based on our project we did, in conclusion, washing machine is an important thing to us, so that we should know a good spin speed. We vary on the types of fabric you have in the machine, for example, wool, synthetic, and cotton. So here I want to tell the spin speed required by each type of fabric. First, if you use wool, it will require a slower spin speed around 600 to 800 rpm. Next, for synthetic, we need around 800 to 1000 rpm, and for cotton, we need 900 to 1400 rpm. Next, the washing machine has 5 sides of the most common motor problem. First, washer won't pump or spin. Second, pump but won't spin. Third, washer won't agitate. And four, clothes stay wet. And the last problem in every cycle.
That's all from us. Thank you.